Hey guys, let's start chapter 7 together. We're talking about linear systems, which we are used to, and matrices, which will be new to us, but it's a shortcut or an easier way to make complex linear or systems of equations easier. Let's jump into this. So today we're talking about solving systems of equations. So some important vocabulary. Systems of equations are just models to solve equations that are in two or more variables. Okay? A solution of a system of equations in two variables specifically is the point x comma y, where it satisfies each equation in the system. So substitution, you probably have used this before, but remember that substitution is a method of solving a system by substituting, aka the reason why that we call it substitution, on or an equation into the other equation for the purpose of solving one variable. A point of intersection, x comma y, is where the solution is. So I want you to start thinking of it now, but a solution and the word intersection are going to be kind of synonymous. And then lastly, the break-even point is the point reached by sales. So this is a real-world application. When enough units of a product is sold so that the revenue, or stands for R, is equal to the total cost, or C, of the product. So the break-even point is when a company sells enough to pay for their costs so that it's not costing them anything. So, okay, so to check that the ordered pair specifically, 3, 4 is the solution of a system of equations, we're going to substitute -3 for x, and you're going to put in 4 for y in each equation. Of the system. And check it. So here's the steps necessary for solving a system of equations in x and y. So number 1, you're going to get a variable alone. And this could be either x or y. You're going to substitute. We're going to substitute the thing that you got alone into the other equation. Step 3, then you're going to solve for the one variable that should be left. So if you did step 2 properly, you should only see one variable in that equation. And then lastly, you're going to use back substitution, or substitute again, to solve for the other variable. Okay? So The solution of a system of equations corresponds to the point of intersection. We highlighted that earlier. This is just a good reminder that it's important that the point of intersection is the solution. And the steps for using the method of graphing to solve a system of two equations goes like this. Number one, you're going to solve both equations for y, meaning you get y alone in terms of x. Step two is you're going to use your graphing calculator to graph both in the same window. So remember to type both functions into your calculator. You're going to hit the upper left-hand corner, y equals. Under y1, you're going to put your first function. Under y2, you're going to put your second function. And then, in order to graph them, you're just going to hit graph. If they're not in the same window, you can hit zoom. Six to reset it to standard. And then step three, you can use the intersect feature. So in order to see exactly where they intersect, here's how you do it. You're going to hit the second key, which is that upper left blue key or other colored key. And then you're going to hit the trace key. And second trace activates the little words on top of trace, which is the little words that say calc. And then you're going to choose option number 5, which is the intersect feature. And that will tell you exactly where that intersection is. Okay, now how do we solve the system of equations using substitution? Go back and look at your steps for solving by substitution. So number one, we're going to get a variable alone. So if I look at this function right here, if I want to get something alone, this piece right here is really nice and easy to get alone. So I'm going to subtract the 2x to both sides. So I get y equals negative 2x plus 2. My second step is I'm going to substitute, hence the word substitution, into the other equation. So my other equation is this one. So I'm going to rewrite this. This is x minus 2 times y equals negative 9. But we're going to use this y instead. So instead of y, what does it equal? It equals negative 2x plus 2. Step 3 says we solve for one variable. We see here there's x, and that's it. There's no y. So we're going to go ahead and solve. If I multiply this, x minus negative 2 times negative 2 is positive 4x. Negative 2 times positive 2 is negative 4. We're going to combine like terms. And then we're going to add 4 to both sides. We get 5x equals negative 5. Divide by both sides by 5. And we get x equals negative 1. And then step 4, we're going to back substitute. And back substitution means we take our answer and plug it back in to one of our original equations. So 2x plus y equals 2, and x is really negative 1. We just found that right here. So now we're just going to solve for y. So we get negative 2 plus y equals 2. Add the 2 to both sides. We get y equals 4. So my final answer, we're going to put in terms of a ordered pair of solution, -1, comma 4. Okay, next one. Solve the systems using the graphing method. So using the graphing method, we're going to first solve for y on both sides. So this one, if I add the y to the other side and I subtract the 5 on the other side, I'm going to get x squared minus 5 equals y. And this one here, I'm going to add x to the other side and I'm going to get y equals positive x minus 3. So now we're going to use my graphing calculator and graph them. So remember, you're going to find your y equals key, and under y1, I'm going to type in x to the power of 2 minus 5, and on my y2, I'm going to type in x minus 3. What that does is when I hit the graphing key, it will look like this. It goes through this point right here. So there's my x squared minus 5. And the x minus 3 is going to look something like this. Okay, that's my x minus 3. Now, to find these 2 points exactly, now I'm going to use step 3, which is hitting the second key, and then trace. Trace is in the upper right-hand area, and then you're going to hit select option number 5, intersect. And because there's 2 of them, move your cursor just somewhere over here close to this button here. So when you hit it, it's going to put itself somewhere on one of the functions, and you'll hit enter. You'll find it somewhere on the other function, hit enter again, and then when it says guess, hit enter, and it will locate for you this exact value, which is -1, comma -4. We know that there's 2 intersections though, so you're going to quit out of that. So hit second mode or quit, and you're going to do that step again. Hit second, trace, option 5, intersect, and then you're going to move your cursor over. So click over, hit your right cursor. You're going to move it so it's closer to this point. Hit enter. It'll move it closer to this point on the other function. Hit enter. It will say guess. Hit enter again, and then it will give you this intersection 2, comma -1. If you can't figure that out, come see me. And then lastly, our application is the total cost C of producing X units of a product typically has 2 components. One is the startup cost, and the other is the cost per unit. Okay, so what a break even is, maybe you've heard about this before. A break even analysis, the break even point is the point of intersection on both of the cost and the revenue curves. So there's a cost function where it costs me to make a product, and there's a revenue function. Where those 2 cross will be our break-even point. So a break-even analysis can also be approached from the point of view profit. In this case, consider the profit function, which has to deal with both cost and revenue. So the profit equals the revenue function minus the cost function. The break-even point occurs when the profit equals 0, meaning I haven't made any money, but I haven't lost any money. Okay, the cost of producing X units, C, the cost is 1.5 times X plus $15,000. This tells me right here the startup cost. And this tells me right here the cost to produce each product. There's 2 parts. And the revenue obtained by selling X units is R equals 5X. How many items should be sold to break even? So if we look up here, remember, to find our break even point, I know the profit has to be 0. Well, I know profit equals the revenue minus the cost. So if I want the profit to be 0 for my break even point, we're going to say 0 equals the revenue minus the cost. Well, we know the revenue right here is 5X. And we're going to subtract from it the cost function, which is right here. 1.5x plus 15,000 equals 0. So now we're going to solve for x. So we've got 0 equals 5x minus 1.5x minus 15,000. So if we combine like terms, this is going to give me 3.5x. And I'm going to add 15,000 to the other side. If I divide this in my, 3.5. I've got 15,000 divided by 3.5. And we've got x equals 4,285.7. So this is how many units we need to sell. But can I sell 0.7 units? So I'm going to round up. So we have to sell 4,286 units in order to actually break even. All right, see.